Section 5.7, inequalities in two triangles. We're going to apply inequalities in two triangles. So in triangles that have two pairs of congruent sides, there's a relationship between the included angles and the third pair of sides. There's a door diagram on page 332, so let's take a look at that one. Okay, yeah, that's not there. Okay, so when you close a door, the angle between the door and the frame at the hinge gets smaller. The relationship between the measure of the hinge angle and the length of the opposite side is the basis for this side angle side inequality. So the wider that the door is open makes the angle bigger, but it also makes that side bigger as well. So the hinge theorem, side angle side inequality theorem, is kind of like our side angle side that we did before. If two sides of one triangle are congruent to two sides of another triangle and the included angles are not the same, then the longer third side is opposite the larger angle. A lot of words, but it comes down to this. So if you look at these triangles and it tells you that A is bigger, BC is bigger than the other one as well. So if this angle is bigger than that one, this side has to be bigger than the other one as well. It's just going to opposite. So what you're going to do is you're going to find the one that's bigger, go to the side opposite, that's the one that has to be bigger. Same triangle, you know, if you're looking for the smaller one, you look for the smaller angle, the side that's opposite goes to, or the side opposite, that smaller angle is the one that is smaller. Okay, so how do we use this one? Which of the following statements must be true? So here are the triangles. So in this one, we have two angles that are given. So those are going to be the ones that we kind of focus on. The square means how many degrees? 90. So this one right here is 90 degrees. This one over here is 70. Okay, so let's look at what they're asking. It's kind of be all over the place. Is AS less than YU? Do we know that? First of all, when you're looking at it, AS is the same as OY. They don't say anything about that in there, okay? OU is the same as AK. They don't say anything about that either. So what they're looking at is if they give you sides that are the same, they're going to want you to find those angles that kind of go with them. So notice how these two are kind of going to be the same, right? If you have two sides that are the same, angle K is congruent to angle U. They don't say anything about that over there, okay? If you look at this side, I'm going to change colors here. This side right here goes with S. So we're going to have angle S is the same as which one on the other triangle? Which one on this one? Look for the double. Which one is opposite the double hash mark? O, Y, or U? Y. Okay, that's what you look for first. It doesn't say anything about them, but that's going to make a difference. So far, it's looking like these two triangles are supposed to be congruent, right? Because you're looking for that third one. So what we're looking at now is angle A is 90, angle O is 70. A is the bigger one, right? So A must be opposite the side that's bigger. Okay, so SK is going to be bigger than the one that's opposite this one, YU. So we look for that one, and that's our answer. Now, would you have had to go through the angles opposite are the same? Not really. You know, if you can find something in here that's comparing the one that you're looking at, that's the one you pick. So if you look at this and say SK is bigger than YU, then that angle that's opposite SK must be bigger than the other one as well. So not a lot of things you can write down, but definitely something to look at. So far, two sides are the same, okay? Kind of like the last one. We figured that we didn't really need the last two, but the reason they have that in there is because this forms the side, this forms the other side in that side angle side inequality. So that's why they're giving you those. So here, this side is the same as this one. Now we can look to see if the angles in the middle make sense. So which angle is bigger, M or P? Okay, so which side should be bigger? LN. So you look for the angle. The side opposite has to be the bigger one. Okay, so LN has to be bigger than the one opposite this one, which is QO. The order of the letters does not matter. Now, could you also say QO is smaller than LN? Yeah, I usually do the one that's bigger just because it seems to be easier for me. So in the directions, I think it'll normally say which is the bigger one, which one is greater. And then you always know that you're going to look for that bigger one first. Okay, so find the angles. The sides opposite would also compare the same way. Okay, the diagram shows the position of a swing at two different times. As the speed of the swing ride increases, the angle between them increases as well. Is the rider farther from point A at time 1 or time 2? So when we're looking at this one, we are looking at how far they are away. Okay, so we're looking at it like this. Okay, so which one are they further away? Time 2, right? Because the angle there must be bigger. And that's kind of what you're looking at. So looking at the triangles, with angle B, it goes to this one. Angle 1 and angle 2. Angle 2 goes with this one. If the angle is bigger on that outside, then the side opposite has to be bigger as well. So we're going to say time 2 greater than time 1. And to explain, we're just going to do side, angle, side, inequality theorem. Okay. They don't really give us angle measures, so you can't really go to that. If they had angles, you could use those. But again, a reason could be that side, angle, side inequality theorem, which is what I think it was called. Yep. You can also call it the hinge theorem. I think it's easier to call it the side, angle, side, but that's just my preference anyways. Okay, on this one, which position is the distance between the tips greater? If you look at the angles, 40 is bigger, so this one must be bigger. So I'm going to say number 2 greater than number 1. And I just kind of explained it in words that time. I could have just said side angle side similarity theorem, side angle side theorem, inequality theorem. The side opposite the greater angle is greater, which is basically that theorem in less words. Then we do the converse of the hinge, is basically the opposite thing. If they give you the longer side, you can also pick out the bigger angle. So it's basically the opposites. You just have to remember which one goes with which theorem. The first one gave us the angles. We compared the sides. This time they give us the sides. We're going to compare the angles. Exactly the same thing. Now, definitely probably write this one down. This is the one that people have trouble with because it is a little bit harder. So I'm going to let you copy. Okay, so what is the range of possible values for x? So remember yesterday when we found a range, the answers looked like 2 is less than x is less than 7, which meant your answers that were possible were between 2 and 7. So we want a range of possible values here too. So you're going to have an inequality at the end. There's just 2 things you need to find. You need to find the upper limit. you need to find the lower limit, and then you're going to kind of put it together in a range of values. Okay, so directions on this one first, and I'm giving you kind of steps just to show you what you do in those steps. But step 1 says find an upper limit. So I'm going to make this a little bit smaller so we can see what we're doing. Okay, so let's kind of put this into perspective here. We have RU is the same as TU, so we have one side. We have another side, RS, and we have another, opposite the angles that are given. One is 15, the other's 10. And the second side that would be the same would be SU congruent to itself. So we do have that side, angle side thing going on, not 3 sides. Otherwise, we'd be looking at angles. So when you're looking at it, 15 is bigger than 10, correct? Which angle then would be bigger, the 60 or the 5x minus 20? The 60. So look for the biggest side, and then you're going to kind of use that one to be that upper limit. Okay, so here's what we're going to write looking at that. If 15 is bigger than 10, 60 must be bigger than 5x minus 20. Okay, or you could put it the other way around. If 10 is less than 15, then 5x minus 20 is less than 60. I like to go kind of the bigger route, but that's just kind of the way that I do it. Now we're going to solve this thing, so I'm going to add 20 to both sides. So we get 80 is greater than 5x, and then we'll divide by 5. Okay, so here's my answers so far. X is going to be less than 16, or I have 16 is greater than X. If you want, no, I'll talk about that at the end. Okay, so we have our upper limit, it's going to be 16. Okay, now how do you find a lower limit? This one is the one that's tricky. To find the lower limit, we already know that this angle right here is 60, and that this one has to be smaller. So it's not going to be bigger than 60. Is there a lower limit for an angle? Like, what's the smallest angle that you can have? It'd be like 1 or less than 1, right? Has to be something bigger than 0. So this is where you kind of got to use your brain, and you have to put it in there like this. The lower limit is going to be that one that we don't know. And we know it has to be bigger than 0 to actually qualify as an angle. We don't want negative numbers here. We want all positive angles. So here I am going to add 20 to both sides and then divide by 5. So x must be bigger than 4. Then we put them together in a range of values. Okay, yesterday we kind of talked a little bit about this. What number goes on the left, the small one or the big one? Small one, 4. The big one goes on the right, 16. The x is in the middle. And did we use less than symbols or greater than symbols? Less than. So same theory as yesterday. You just have to know how to put them in there. Now, how would you do that if you're like, oh shoot, I forgot if they're less than, I forgot if they're greater than? What you're going to do is you're going to make sure that this x is in the middle. So for this one, to make the x in the middle, I would have to rotate it. It would be 4 is less than x. Okay, which is what it says here, 4 is less than x. And on this one, the x again has to be on the left side, so I have to flip it over. And if I do that, it becomes a x is less than 16. And then you just have to put them in there. So small number on the left, big number on the right, less than symbols. I'm going to give you some hints here. You might want to write these things down. If you are looking for angles, and this has to be in your notes, not in your postulates or theorems, the smallest one has to be greater than 0. That's the one that gave us that last equation that we were looking for, that lower limit. The largest one has to be less than 180. So let's say, and this is going to be or, it's generally going to be one or the other. One of them you're definitely going to have an inequality that you can solve. So if we would have had the smaller limit, like if we were looking at one and we knew that it was bigger than 20, well, if it's bigger than 20, isn't it already bigger than 0? So you're going to use one of these. If you know the smaller one, the bigger one has to be greater or less than 180. If you know the bigger one, the smaller one has to be bigger than 0. It's one or the other. Okay, now what are we going to do if we have the angles and we need the sides? Okay, so we're going to do one more just so you can see it, and I'll probably give you, something like that too for the next one. What is the range of possible values for x? Okay, that's not the one I wanted. No, we'll do this one anyway. We'll maybe find one in your assignment because this one looks like you're looking for angles too. Okay, so we have side, angle, side. We have side, angle, side. So it looks like we are good. This angle right here is 90 degrees. It goes to the 9. This angle right here is 3x plus 18. It goes to the 7. Okay, so I'm going to look for the bigger one. 9 is bigger. So which of the angles is bigger, the 3x plus the 18 or the 90? 90, because it's opposite the 9. So I'm going to say 90 is bigger than 3x plus 18, and we're going to solve that one. So we subtract 18 and divide by 3. Okay, so 24 is bigger than x. Generally, we want the x on the left side, so if you want to change it now, you can. If you flip it over, it says x is less than 24. Okay, and 24 is kind of a big number, so that's probably our upper limit. Okay, then we look at this. If we have the bigger one, which we do, we need to look for the smaller one, and we need to know that 3x plus 18 has to be bigger than 0. So we do not have the smaller angle. That means we need to look for it. So we choose the one that has to be bigger than 0. So I subtract 18 and divide by 3. Now, the other day, you might be thinking, but we can't have negative angles. It's not really a negative angle. We just have to choose values that are bigger than -6. So if I plug in a -6 right here, I get 0. That means anything that I plug in beyond -6 will work. Okay, so it still is okay, even though it's a negative number. My smaller number is -6. My bigger number is 24. The x goes in the middle, less than symbols. So same thing. So it doesn't really matter if you don't know where they go. They always go in that order. Smallest on the left, biggest on the right. Do not flip them over. I don't want greater than symbols because that's not how you say it. It's x's between -6 and 24. So you would choose all the numbers that are in between both of them. Now, here's a proof, and I just want you to write it down just so you have one. We're not going to focus a lot on the proofs, but there might be an occasional one in the assignments that you need to look at. This one is the first one that we've actually used inequalities with, so I'm going to give you a minute to write these down. It is 1, 2, 3, oh, hold on. 1, 2, 3, 4, 5. It's 6 steps. So if you want to. Okay, so we are given that BA is equal to DE. They have it marked in the picture. They have BE is bigger than DA. That you can't really mark in the picture. So BA or BE, that's the hypotenuse of the left-hand triangle, and DA is the hypotenuse of the right-hand triangle. So next thing is the one that we are very used to. What is the reason for AE congruent to AE? This one right here. How is that one congruent to itself? Reflexive. So even if you don't know anything about it, you guys, I think, are good enough now where you would recognize that. Reflexive property of equality, since there's an equals in there. How do they know that the measure of BAE is bigger than DEA? So they're comparing this one to this one. I'm going to put 2 there just because they're not the same. Remember at the beginning when they said BA is equal to, or no, BE is greater than DA? They're saying that this side right here is bigger. Well, wouldn't the angle opposite it be bigger too? We just learned that today. So I'm going to say converse of the hinge theorem. So when we know which side is bigger, the opposite angle would be bigger as well. The next one they say is the measure of DEA is equal to the measure of DEB plus the measure of BEA. So they're taking this angle right here apart. And they're saying that this whole entire thing is equal to this little part right here plus this little part right there. We have done that before. Oops, that is the angle addition postulate. I usually say AAP, but we haven't done these for a while, so I wrote it out. So when you're looking at the next one, they have DEA. That's the one they started with here. Remember yesterday when we had 2 things added together, the one that was the one that it equaled was bigger than both of them separately. So they picked this one, and then they picked one of those 2. Well, if it's equal to the sum, it has to be bigger than the both of them together. So I'm just going to say comparison property here. And equality. So it doesn't look very good. And then when you use these 2 together, you get this one. So at the beginning, BAE is bigger than DEA. Well, DEA is bigger than BEA, so this one must be bigger than that one. So transitive property of inequality. So we haven't used that before, but they're kind of using those together. Anytime those middle terms are the same, the first one has to be bigger than the last one. I'm going to go back and have you write down one more thing, and it's where we had those angles. I should have done it back then, but I didn't. Okay, so I'm going to go back a little bit. So I gave you a little tip about when the angles are the same. What about when the sides? Okay, so here is when you're looking for angles. What do you do when you're looking for sides? So this was looking for. Okay, when you're looking for sides, is there any limit to the side, like the biggest length of side? Sides don't really matter. We could have 1,000, we could have 60, we could have 5. The upper limit doesn't matter. So I'm going to say there is no upper limit. So meaning the number that we have, it doesn't really matter. What you're looking for is if you need to know the lower limit, this is the one that you need. The lower limit just has to be bigger than 0. So basically your lower limit has to be a positive number. So with angles, there's 2 of them. You know that the highest one has to be less than 180 and the lowest one has to be greater than 0. For sides, the lowest one, or let's say small, has to be greater than 0. And there is no upper bound. It can be whatever it happens to be. So you don't have to really look for an upper limit for sides. It doesn't really matter. You would have to go, okay, if I'm looking for the smaller one, all I know is it has to be bigger than 0. If you're looking for the biggest one, then it doesn't matter. Okay, so keep those 2 things in mind, and let's look in the notes to see, or look in the assignment to see if there is one for sides, because we didn't really do one of those. So we're going to look for that right now.